Adjunct Professor Moran, Microeconomics 112. We're going to discuss the last measure of elasticity of demand, the total revenue test. We discussed the descriptive method, many substitutes, luxury versus necessity, percentage of income, and durable versus non-durable. We discussed the steepness of the curve. We discovered the arc midpoint formula, and now we're going to take the test of the total revenue to determine elasticity of demand. Total revenue is not profit. Total revenue is price times quantity equals total revenue. If you buy one Happy Meal for $5, $5 is in the cash register. If you buy two Happy Meals for $5, $10 in the cash register. That's total revenue. Total revenue, also known as sales, minus cost equals profit. So we're not focusing on cost here, we're focusing on total revenue for this application. Total revenue, price times quantity equals total revenue. Total revenue is a race between price and quantity because demand is a negative relationship between price and quantity. You know if the price goes up, quantity is going to go down. And if price goes down, quantity is going to go up. The question is, what is the relative weight each one has? If you increase price by 5%, then you know quantity is going to go down. If quantity only goes down by 3%, then the amount of money the increase in money per unit you get will offset the fewer number of units you sold, and this is a good idea. Your total revenue will go up. But if you increase your price by 5% and quantity falls by 7%, although you're making more money per unit, you're losing so many units sold that your total revenue will go down, and you wouldn't want to do this. If price goes down by 5% and quantity goes up by 3%, then you're making less money per unit, and it's not the amount of increased quantity demanded is not offsetting the decreased price per unit, so you wouldn't want to do that. But if you decrease your price by 5% and your quantity demanded changes significantly more, maybe to 7%, and although you make less money per unit, you're selling so many more units, quantity demanded, your total revenue would go up. As a result, we can summarize this by saying when price and total revenue move the same way, price increase, total revenue goes up, you're in the inelastic part of a demand curve. When price goes down and total revenue goes down, inelastic. So obviously, if you're in an inelastic range, you would want to increase your price. Although you'll sell fewer units, your percentage increase in price will offset that decrease, and your total revenue will go up. You would not want to put your product on sale if you're in an inelastic range, because a decrease in price, although you'll sell more units, will not be the change in quantity will not offset that percentage change in price. But when price and quantity move opposite directions, you're in the elastic range. An increase in price will cause quantity to fall, and that decrease in quantity will more than offset the additional money you get per unit. So you wouldn't want to increase your price in the elastic range. Instead, if you're in the elastic range of a demand curve, you would want to decrease your price. Although you're making less money per unit, the corresponding increase in quantity will more than offset that, and by decreasing your price, you'll increase your total revenue, the elastic range. And if you remember from the prior discussion, each demand curve has an elastic and an inelastic range. The elastic range is always on the upper left. So here you would want to decrease your price, which would cause a percentage larger increase in quantity, and your total revenue will rise. In the inelastic range, you would want to increase your price, because although you'll get fewer quantities sold, the percentage increase in price will more than offset the decrease in quantity sold, and your total revenue will rise. And the best place to go in this particular application, we'll see in another unit that all prices will be set in the elastic range. But from approximately here, though, this is elasticity equals 1, and that's unitary elasticity. Inelastic, unitary elastic, elastic. Prices will tend to here to maximize total revenue. To demonstrate this, instead of doing it on the sheet that we've been working on, we're going to use this worksheet, which summarizes it a little better, posted online, and has the answer key of how to classify it. So let's say the price goes from $1 to $2. Okay. At $1, quantity demanded is 180. At $2, the quantity demanded is 160. So if we go from price. Let's see. What are we going to do? This price $1 and $2. I price $1. Let's do it this way. $2. At $1, the quantity demanded is 180. At $2, the quantity demanded falls to 160. That gives us a total revenue of 180 here and 320 here. By increasing price, total revenue increased from 180 to 320. As a result, this is an inelastic range. Price and total revenue are moving the same way. If price falls from $2 to $1, then at $2 we have 160, at $1 we have quantity demanded of 180, then our total revenue goes from 320 to 180. That wouldn't be a good thing to do. When price decreased, so did total revenue. This is also inelastic. But now let's look at 5 to 6. 5 to 6. At $5, quantity demanded is 100. At $6, quantity demanded is 80. So 5 to 6. Quantity demanded at 5 is 100. Quantity demanded at 6 is 80. Total revenue is 5 times 100. 500, and 6 times 80 is 480. So price increased and total revenue fell. When price and total revenue move the opposite way, it's elastic. But if we go from 6 to 5, our quantity demanded at 6 is 80, our quantity demanded at 5 is 100. Our total revenue at $6 is 480. He puts it on sale at 5, his quantity changes to 100. Now he lowered his price and his total revenue increased. This is elastic. Lowering his price, total revenue increases. They're moving in opposite ways. And so that's the total revenue test. And this explains pricing behavior. If you owned a business, you would definitely want to know how customers are going to react to a change in price. Increasing your price, you're hoping to make more money per units. But what's going to happen to the quantity demanded as a result? It will move the opposite way. If the change in quantity offsets the change in price, the decrease in price is more than offset by the change in quantity, then you would want to put your product on sale. That's elastic. But if you lower your price and quantity demanded hardly changed at all, that's inelastic, and you would not want to put your product on sale. This explains why things at Best Buy, durable goods for example, are always going on sale, which is elastic, but gasoline, which is inelastic and has few substitutes, never goes on sale.